We'll talk about FOSS in education. We have a brilliant panel lined up for all of you, but I just wanted to take 5 minutes to set up the context on why are we even talking about free and open source software in education, right? Uh, what is happening with Indian edtech? I know it's a taboo. You shouldn't even say this word edtech, right? But I think it started sometime around the COVID-19 pandemic when everything just went online, overnight, and institutions struggled to change their systems, and it was just rapid adoption, and a lot of us did get used to it, but in that process a lot of students, a lot of institutes were left out because not everyone could adapt to this new form of technology, and it was very unequitable sort of a shift that happened. Of course, the GDP contribution of edtech increased, and we saw so many unicorns that were required and all of that. But this has led to a wide access gap, and none of this really solved the problems that we've always had with the education ecosystem. We still have the same number of dropouts. Affordability is still a huge problem. Uh, and while all of this shift happened, proprietary software became a huge thing in education. But what are the dangers of closed source software in our education system? One, of course, it is very costly. There was a study in 2009 that pointed out that India can save around 8,000 crores if all of us switch to open source software, just in the education sector, right? And recurring license fees, all of this is it's a very high cost item, and a significant portion of your fees does go towards education institutions just paying for licenses year on year. And we do have policy which recommends adopt education institutes to adopt free and open source software to get rid of those costs at very almost for free and negligible costs. The second is, of course, lock-ins. The business model of these companies is built around keeping you logged into their ecosystem. They will not, once you started using it, once you've developed some curriculum, they will not allow you to be able to move on to a different form of software, right? And more importantly, these ecosystems force students to adapt to a specific learning environment. These systems force teachers to adapt to a specific teaching environment, so you cannot be creative, you cannot customize these solutions, which is again which is just the opposite of how education should be. Like, everyone should have their own way of teaching and learning. And we did see this time and again in the pandemic also. A lot of institutes were using softwares that a vendor built out for them, and they were not able to scale all of those things. Privacy, of course, is a huge it's a huge threat. We regularly see huge amounts of data breaches that happen. These platforms collect humongous amounts of data. We don't know what's happening behind the scenes, and yep, it's just. But what does FOSS stand? So FOSS stands for free and open source software, in case anyone didn't know. But from a philosophical point of view, free and open source software stands for these sort of values, right? Freedom. There's always collaboration and a community around these projects. Any open source project that you see, there will always be some sort of community around it, which is very similar to education, where you work together with your peers and all of that. And like education, it is also ethics driven, it's not profit driven. And of course, it's equal. Like, no matter where you are, what your economic background is, like, this software is accessible to you, which is why I think FOSS makes a lot of sense in education. Both academia and FOSS as a domain, they have very idealistic goals. In both the places, one thing is that you'll hear very often is that any outcomes that you want to achieve, that can only be achieved if you're working in the open and if you're working with other people. Like in college, you would see your professors are always asking you to, publish research papers, go talk at conferences. All of this basically means that you have to go out there and talk about what you're doing, right? And from what we've seen, FOSS is actually an implementation of all of these things. A lot of successful open source projects have come out of academia. Linux came out of academia. GIMP was a college project. So, FOSS, in my opinion, it's just a way to create discourse around the findings of academia, which is why I think these are so connected, and it just makes so much sense to me. And of course, if you're contributing to an open source project, it's so much better than making yet another to do list, right? Because you're working on something where you're solving a real world problem. And more than that, a real world problem that actually has users. So you're solving something that is useful, and it gives you access to a community. It gives you access to a lot of humanity kind of skills, right? Because you have to work with other people who are present in all corners of the world. So that kind of skill you can never get from a traditional setup where you're just working on a project, even in a team in your college, right? And a very good example is, of course, Wikipedia, which allows anyone to edit information. And of course, that creates mistakes, right? But that's not the goal of Wikipedia. Like, you can create mistakes, which is very similar to education. While studying, our goal should not be that we have to create the best sort of thing. We don't have to aim for the right outcomes. We have to aim for fixable outcomes. Like, it's okay to make mistakes. These mistakes should be debuggable, right? And of course, open source software is mostly a tangible solution to all of these problems that we pointed out. And yeah, with that, we'll start with the panel. But yeah, I think Dr. APJ Abdul Kalam summarized this really well in a speech that he gave some 20 years ago, where he said that the reliance of Indians on proprietary systems is a huge threat, and a very small change in how these companies work can have massive amounts of impact on, how our lives are structured, and which is why open source software needs to come in a big way for the benefit of our billion people. With that, all of the panelists, please come on stage. We'll start. Please give a huge round of applause for everyone. Thank you. Hello. Thank you very much, all of you, for joining us today. We'll start with introductions. Why don't if you, all of you just take a minute, talk about your work. Also, some of your work in either the FOSS ecosystem or in education or both. So yeah, we'll start with that.
My name is Dipankar Sarma. I am a software architect at Agrani Labs, which is a semiconductor startup. We are actually building a AI chip basically, and I work on the software side of the chip basically. But my background is essentially for a long time operating systems. I was with IBM for a very, very long time, many years, 29 years at IBM, and I worked out of 29 years. More than 20 years, I worked on Linux operating system. I was working in the community quite a bit at that point in time. I was the original author of read copy update synchronization primitive in Linux, which is now used in tens of thousands of places in the Linux kernel. I was a subsystem maintainer also for a long, long time. Now that I work quite a bit on the hardware side, I'm not spending a lot of time in the community, but I still write a lot of code for the current company. And just to add Kailash's point, and I completely agree with him about the LLMs. It is a dangerous tool in the hands of a very, very experienced engineer, someone who has spent 29 years writing code. So that's my background. Very long association with the Linux community. I have done some contributions to other software, open source software communities as well, but predominantly in the Linux community. So I'll kind of bring that perspective. And of course, I'm also like a very old alumnus of this institution. So just wanted to add that point. I'm wearing a t-shirt as well.
Morning all. I'm Rahul. I'm the CEO of FOSS United. I've been with FOSS United for a couple of years now, and I've been trying to help a lot of the programs that we're running. Before this, I was a scientific software developer. It's a role that most people don't even know about. My background is in physics. I did my bachelor's and master's in physics, and then I moved into like scientific computing because like that's where I wanted to try and keep my interest in physics alive and do a bunch of the scientific and computing stuff, which was beginning to get more and more interesting. As part of my work for 8 years with this small company called Enthought, I contributed to a bunch of open source packages that they had created, mostly again in the scientific Python ecosystem. Like deeply involved in the Python community for the last 8 years. Just a bunch of contributions to packages again in the scientific Python ecosystem. Most of my community contributions were when people were running away from Python 2 to Python 3 and did a bunch of changes where I was just getting rid of Python 2. I don't even know if people here know that a version Python 2 existed and how difficult it was for people to switch over. But yeah, that's where most of my community contributions are.
uncle's uncle. Okay. My first program was when you had to address individual pixels on the screen. So I wrote an assembly line code to join the pixels to draw a line, and thereafter to fill an area and so on. And my first memory was that I was a student at IISc Bangalore when the very first IBM PCs landed in India in 1996. Okay, so your parents might have been born. I'm not so sure. So and I want to write games. So I want to write a game. So in Bangalore there used to be this racing club. So I used to go to racing club to find out what the rules are. See, there was no internet at that point of time. You must realize that. So I went to racing games and found the rules of the game. And my students thought I was betting on the horses. I didn't have enough money to bet on the horses. Come on, barely enough money to pay the mess rent and so on. So those were the days. But to the FOSS community, one of the things I am proud about is that I wrote a software code for simulating liquid metal flow in a mold and so on, which people say is rocket science for rocket scientists. Very, very tough, very difficult equations, very graphics intensive, UI intensive. I had to do 3D line-to-line intersection without the computers crashing. So I have been there, done that 40 years back, 30 years back. But one of the things that I did later on, which I put on open platform, was that the software was so complex, people were not able to use it. So I created a whole lot of exercises, games, videos, and everything else, and put it on a website called eFoundry. But and eFoundry is real foundry, not the chip foundry or semiconductor foundry. But I had my struggles because as a faculty member, how do you manage the server and things like that? So today morning, my thought is through him and through him, I'll give my entire code to you and see if we can put the whole thing on an open source. So it lives beyond me, okay? So the whole point is to make sure that, I'll make one other comment, but I think I'll reserve it for later. I'll let the round start, okay? No, I was just discussing with him that what about AI is scary, okay? And our faculty truly are scared about AI here. Either they are scared or they're ignoring AI, okay? Hopefully, okay? So I'm telling them it's like a tsunami, okay? Did you see the tsunami? Where? I can't see. It's right behind you. You don't want to see it, okay? So AI is going to change the employment and education both, okay? And we have to respond to that. And my hope and pray to faculties, if they don't come in your way, that's good enough, okay? Good enough. You guys just do it. Don't worry about faculty, in my opinion. But I'll make a last statement here before. AI, what is AI and what it is? I was just making a small, simple example that an EV, another 5 years, 10 years down the line, you just get into the EV in your house, EV will know where you want to go. Or you just think that I want to go and it'll take you there. But what if it breaks down somewhere on the way? And it has a steering wheel and a brake, but you never learn how to use a steering wheel and a brake. That's going to be a very scary situation. So we got to still think about human intelligence. Let me call it AI versus or natural intelligence, NI. So humans have something which computers still don't have, which is knowledge part of it is now forget about it. Information, though, forget about it. Knowledge also, you want to learn a subject, it's pretty much there. And you can ask, okay, you want to design a bridge, design a code, it's possible. You just have to tell them. But I think beyond that, I would say human experience, which you get by interacting and by real work and real life. And beyond that, intuition, which you don't even know where it happens. When I was a student, I used to keep a notebook and pencil next to my bed. Suddenly something strikes with you at 3 a.m. or 4 a.m. in the night. And you think, okay, I'll remember this when I get up, but 6 a.m. or 7 a.m. you've forgotten. So I used to keep a notebook, even algorithms and data structures and coding and stuff like that. So intuition strikes you and you never know. And intuition is not programmable. Hallucination is not the same as intuition. Okay, come on, okay, both are different things. But beyond intuition, our feeling of empathy for each other, computers will never ever have feelings or emotions. We see another person and then person is suffering or whatever it is, we take some steps. Okay, computers are cold. They won't be able to do that. So I think in the whole game of whether it's a free open software or any software or AI era, we got to even more strengthen our humanness or naturalness and preserve that and keep connecting with people like that. This conference could have been done online, but it's not going to be the same. Nothing like meeting face to face, right? So welcome to NITK. I wish all of you have a great time, and also you also make new friends. Please go to the beach. We have, I did chat GPT yesterday for some other meeting. I found this is the only institute with its own beach. So please enjoy that.
Yeah, I'm Mohit. I'm working in NITK from about 13 years. So, sir is our director, sir, Professor B. Ravi. Sir didn't mention the name, but our director, sir, who has been immensely helpful to us. And ever since I have spoken to him about open source initiatives, he has always been supportive, and he ensured that despite having a couple of other appointments in the morning, he made it here. So thank you, sir, for being here. So yes, I'm Mohit, and I'm working in computer science department from last 13 years here. I first started using open source when I was doing my master's, and I primarily work on networking technologies, basically related to network protocol design and engineering, and continued to use open source tools in my PhD. But when I joined as a faculty, there were quite a few things that became challenging, and I took the open source route to solve some of those problems. The problems that I was facing was during my time when I was doing undergraduate and postgraduate studies, the assignments would be given common to all the students, and then some 10-20 would do it, and the remaining 70-80 would copy it. And it was okay when I was a student, but when I became a faculty, it was a bit of a concern. Because not because I had any worry about who is copying, but I always had one fear in my mind that I should not end up giving more marks to the one who copied than the one who originally did it. So my logic was very simple. Okay, you copied it, is your choice, but how do I as a faculty ensure that I motivate those who did it? Because it's very easy to demotivate them by not giving them the due grades or the weightage that they got. So how do I solve this problem? The only way I could have solved this problem was to avoid giving common assignments and start making assignments that 2 or 3 students can do in a group. But now where do you get the projects? That's where I used open source. So I was using tools like Network Simulator 2, Network Simulator 3, and we continued to work on it during my PhD. So I went to the community and I said, guys, you have so many open issues. Can I take one of these open issues and put it as a project assignment, and then 2 or 3 of my students will try. If they can fix it, we will fix it. If not, they will learn something out of it. But can we do this? And when I started this, students were excited about it, but they said, how are you going to grade us? Because suppose if you are not able to fix that open issue, and if it doesn't get merged, I said, let's take a look at the effort and the discussion that you have on the open source community in an open forum, that I as a teacher can see my student is interacting with the best of the people outside. And if I see that you are putting an effort, and I see that you are genuinely stuck in something which you cannot solve in the duration of a semester, I promise I'll give you full marks for the assignment, even if the project doesn't get over. So I started adopting these approaches. It has been now 10 years. I'm very happy to tell you that a 5th semester student from NITK built a brand new packet scheduler for the Linux kernel. And it's been a part of the Linux kernel from now 4 years. And Quantum Networks company, which is sitting here and has sponsored us, has kindly come forward, and they have given me their access points which are outside. You can visit them during the lunch break. We have put our algorithm in this access point, and we are running tests right now, and we are trying to convince the Quantum Network team to do pan-India deployment, and their pan-India deployment is huge. They recently cracked an order from some of the best hotel chains, including all the Hiltons and all the Accord chain of hotels, and all these big hotels. They have recently cracked the order, and all these access points that they are building will go into the best places in India and all across India. IIT Goa campus is fully Quantum Networks. The Delhi University is fully Quantum Networks. The Bollywood Film Festival that happens, it's Quantum Network. There is nothing more proud than seeing your own students' work, getting into a real deployment, and then going across the world and making a difference. So all that we do in our courses is try to build new network protocols or optimize the ones that are available. My primary focus is on cutting down latency, because latency is something that people are worried about. So anything related to DPDK all the way to Linux kernel packet processing is what my students do. And open source has tremendously helped me in ensuring that my students are doing state of the art work and we are not becoming obsolete, and ensuring that they graduate with something on their CV about which they can proudly speak any day, anytime without any preparation. So that's what I'm doing here. That's it. Thank you.
Yeah. Thanks, everyone. Again, a very diverse panel here. I think one perspective we are missing here is students. So, all of you, whoever, if please keep your criticisms, any questions you have, we'd love to hear from you at the end also.
I was a student here once.
We are all students of life also. So. Professor Ravi, I'll start with you. I think I'd want to understand what does technical education look like today, right? And how has it evolved over the years? Like I've only heard stories of how people used to use Turbo C++ and all of that. And when I was in college, I think cloud and data science and all of that was the trend, and I'm sure it's AI now. So how does an institute sort of evolve to these trends? Do they even look at them? Does pedagogy also change accordingly? And so how have things at NITK evolved, and what role has open source played in it?
As short as possible. The event that I was there just before this was the batch of 1976 who graduated 50 years back. So that means they are 77 in their 70s right now, right? So, and I asked one question to them saying that, and that many of them have done very well in life and all that. I asked the question, and this question I've been asking to many alumni, and now I ask him also on the stage right now. So I tell him, sir, very proud of you as an alumni of NITK. And what percentage of your success today would you ascribe to inside classroom theoretical teaching learning by those faculty? You got the question, right? What percentage of success today is because of inside classroom?
So I am probably I know all people in my batch will not have the same opinion as I
Tell
do,
me yours. Okay.
because I actually ascribe a very significant percentage, because I remained in the core.
Just a number.
I would say, I would say probably 50%, a very high.
It is the highest I have heard so far in my life.
Because
let's talk about the average.
I will talk about why later on.
Later on you do that. What will be the average of your batch if you think?
Very low.
Okay, so
it is going to be 10 to 20%.
He's an outlier. The average in my head, I said out LIER, not LIAR. Okay, get your language right. Okay. So we are in very, very different kind of times. And I've been telling our faculty here that if 80% of the value comes outside the classroom, why are we spending 80% time inside the classroom? Okay. I've been on a battle here for the last 2.5 years since I joined as a director to get that number down. I'm very happy to say that finally, after a lot of bargaining, we came down to 50-50. Okay. So I said that 50% time inside classroom, 50% outside, and 50% outside comprising labs, which traditionally are 15-20%, but the remaining 20-30% from life skills. Okay. Physical activities, 5%. Creative activities, 5%. Technical activities, building something with your hand, 5%. And getting on a stage and speaking, he's speaking beautifully. He could be my grandfather, okay? What a wise person. Every sentence he spoke is full of wisdom, okay? Wisdom usually comes from gray hair or no hair, but he full of hair, okay? Beautiful. So you guys are smarter than the generation before you. And 3 generations before you definitely are smarter than that. So I'll make it in a different way. A problem with teachers is they can speak forever. So I have to really control myself. But I'll tell you the kind of teachers that I would love to have. I went to Kailash Mansarovar once. Okay, the person who took me to Kailash Mansarovar goes around it every year. So for me, he is class A teacher. That person who walks the path and takes others like me with him. I'm class 2 teacher in this context. I think I'm a class A generally, but I have done the coding and I can teach coding. I have done product development and I can teach product development. I have been there, done that physically myself. How many faculty you think? Okay. If you think engineering is a professional education, like medicine, like law, like finance, would you learn medicine, learn how to do a heart surgery from someone who has never done a heart surgery before? Or law from someone who's never fought a case in court? Or accounting for someone who has never filed a real balance sheet in life? But you can learn engineering for someone who's never engineered a product, hardware or software. How is that even make sense to me? It doesn't make sense to me as a teacher or an engineer or a faculty. So it's a big battle out there. So my quick 2-sentence completion of this question is, we are now approved a new curriculum structure at NITK, which is the first time perhaps in the country, at least in India, I can say first time, and forget about IITs and all the places. I'm from IIT Bombay, so I know what I'm talking about. Where we have a bold, balanced, and beautiful curriculum, hopefully. And number 2, bringing a lot of life skills into the whole thing. But pedagogy is the real game. You give a bad curriculum and a great teacher, doesn't matter, he will still deliver stuff to you. You give a great curriculum to a teacher who has never done anything in their life, it's not going to be helpful. So pedagogy, how do you teach? You can't be turning your back to the class and then write on blackboard and hope that students will. This is a new generation, very impatient, very digitally savvy. They have knowledge. They will learn more from teacher in the same class by going to AI and ask very hard questions which teacher cannot even think about. So the first react teachers is, don't ask questions in my class. That's not the way you learn. In my opinion, the whole class should be nothing but questions and answers. So I used to take actual physical products into my classroom, and I eventually had enough. I would give one to every bench and saying, let's figure out what is wrong with this casting. And by questioning and interaction, and let the students make mistakes. They learn more from making mistakes than by learning the right way to do things. So there are many aspects of the thing. We are doing some bold experiments at NITK. Hopefully this year we'll see the thing. And you tell your teachers wherever you are from, check out what NITKs are doing. If they even some conversion happens among your teachers. As I said, class A who walks the path and takes them on the path. Class 2 who has walked once and then tells students, okay, fine, that may be something, it's good to go to Kailash. Class 3 teacher is someone who's heard about Kailash Mansarovar and tells the student who wants to go to Kailash saying, I have not gone, but maybe here is a map or here is a phone call and do that. But class 4, I don't want. What is Kailash? Why do you want to go there? I'm talking about Kailash means in some stuff. You want to do a new experiment or a new coding or a new... That's what Kailash is for you and me. So I want all teachers to be class A or 1 or 2 or 3 at least. For me is far more important than curriculum or whatever it is. Just be human beings, let the students explore, experiment. You learn more from that. But the system should enable that. Thank you. But tell the teachers. Okay. Director of NITK was saying like that. And let's see what happens. We have some fun in life.
Deepankar, because you ascribed such a high percentage to technical education contributing, what was that like?
Yeah, I think part of it is because I actually took my labs very seriously. Of course, I'm not even not talking about the theory classes and the classroom teaching. I was talking about the years I spent in the lab. I used to spend every night, pretty much all the whole night, working in the old CSE department, and then go back to my hostel at 4 o'clock in the morning. So the 3 years I spent working in the lab, actually, so I would admit I am an outlier, and I remain in core computer science. I'm an OS and a computer architecture background person, right? So I remain in the core computer science. By the way, and just to talk about open source, Linux is not my first rodeo with open source. The first actual exposure to open source was actually right here at NITK. Believe it or not, I predate Linux. I predate pretty much all the open source projects that you currently have, right? My first exposure to open source was IBM PC BIOS listing. And Dr. Hebber, who was a faculty here, he was our head of the department and was teaching a class and labs. He had like an original IBM PC BIOS listing book, pink colored book, basically. And he gave us, generously copies of that book, and using that, I could figure out how to program disk controllers, how to program floppy disk controllers, hard disk controllers, how to do interrupt service routines, and so on. That became, and then we actually went and did a lot of that work in the lab. So the point is not so much about classroom teaching, but it is more about actually having the exposure of building something in the lab. And I completely agree with Dr. Ravi, right? You have to build. Engineering is all about building stuff. In textbooks, in textbooks, in your classroom material, you learn about finished products. You learn what the finished engineering, finished technology looks like. In open source world, you actually kind of go through the process of all the debates about the design, all the issues that you come across, all the sort of like the implementation challenges and so on. You go through that entire process. That is real engineering, and that is real engineering learning, not what you see in, I mean, you, of course, you have to learn about the sort of like the fundamental, sort of, fundamentals of the technology, but the real learning process is, actually being immersed in the process of actually building the whole thing. And open source kind of gives you that exposure of sort of doing that. Unfortunately, I predated most of the open source projects that are very popular, and I predated internet as well. So I did not have that level of exposure. But for the current generation students, I mean, the situation is completely different, right? You can immerse yourself in a very different form of pedagogy, in my opinion, right? And I think all of us are alluding to that, right? It doesn't have to be the way, the way we did it, or maybe I and a few others did it, in terms of spending endless hours in the lab. Right now, you have a lot many more tools available to you, lot many more communities to engage in, learn the actual engineering process, learn the process of building, and then go from there, rather than what some of us outliers actually had to do in the lab. So that would be my kind of explanation of why I think the institute still, kind of had a very good contribution to, where I am at the moment.
Yeah, no, thank you. We'll talk about now finally FOSS in education and what is the state in India right now, right? Professor Mohit, you've been doing a lot of work on integrating open source in academia. A lot of work to sort of create an open source culture. So if you could just briefly, you did mention some of these things, but if you could briefly talk about how you've been able to integrate FOSS in academia at the campus and across, if possible, three aspects. One is adoption. How do institutes adopt open source? Secondly, creation, like how do we encourage students to solve problems that exist at their own campus? And last stage, I think, is contributing to actual projects, right? So across all of those three things, if you could briefly talk about open source at NIT.
Sure. So the only thing that I have done to integrate FOSS in my courses is I have tapped the potential of course assignments. So now that sir mentioned about the revised course curriculums and other things, there's one thing which we are looking at. So out of 100 marks that the students get at an ITK, the institute rule until now, which will change soon, says that 20% of it should be minimum for the mid-semester exam and 40% of it should be minimum for end semester exam. But it leaves 40 marks extra for me to decide what I want to do as a faculty, which I would want NITK to change and make it only 20 to 25% mandatory through written exams, make it 70 or 60% through open projects. But these 40 marks are sufficient enough for me to convince the mindset of my students, because these 40 marks can make their grades or break their grades. So I tapped this potential of 40 marks and I started adding open source projects as official course projects. So one thing that I understood is marks do carry an incentive. And we should try to give some marks to students who are trying to use open source and trying to contribute back to the community, or at least trying to put an effort to understand how open source works. And all the projects that I do is, I think I showed it to Rahul last time. So I have a pretty long PDF file of about 15 to 20 pages in around 50, 60 projects are listed every semester. And these projects are all curated by me by going across all networking platforms, and I see who has an open issue on what. And I do the judgment of whether this fits into a 2 months project or a semester project, or will it run beyond a semester. So that feasibility I have to do. And I also see my comfort level, because when my students will contribute or they will start talking to the collaborators, these all maintainers in open source are also busy. They have limited time to focus, and they are not supposed to do my job. They are supposed to help my students. But before I forward my students' work to them, I should have the ability to look at their code and do the first line of review, and at least do the sanity check and do all the first round of code checking. Only after that I permit the students to upload the code to the main repositories of kernel or NS3 or any other open source tool. So my answer to the question is one thing: if you have a university structure wherein you have flexibility to give the course assignments the way you can, then I think we should tap that and try to see that students have more tangible outcomes from the courses. I mean, I have a question. How many of you have done course projects that you still remember and would like to write on the CV? That's the answer. I would want to make course projects so powerful that they, even after graduate, next 5 years, one of those projects should be on the CV saying that, no, I did this really well. And I'm very happy to say that from so many students are right here who have been taking my courses. And just 2 days back, one girl, she's in Georgia Tech, and she wants to do an internship in India. She doesn't want to be doing internship there. She sent me a CV and she said, can you help me get some internship in Bangalore? And I'm so happy to say that she graduated 3 years ago, and her CV still has the project she did as a part of the course assignment. So the moment you make your course assignment so powerful that students want to do it, even when the semester completes and I have given them full grades, they continue to work on it during the summer. They continue to work on it by themselves because they understand the value of contributing to that project. So I think we need to bring it into the DNA of the whole system, saying that let's make projects that actually matter to somebody. And I have a nice one paragraph in my PDF. I'm happy to show you to all. I list 50 projects. At the end, there's a table. Who cares for these projects? Okay. So I say, Professor Tom Henderson from University of Washington wants these 3 projects to be done. He will be the direct mentor for you along with me. IETF needs these 15 projects. The Linux kernel community needs these 3 projects. There are takers on the other side as soon as this project is done. And when you create projects like that, whether the students do or not, there is immense learning in that. That is the most important thing. And then let me tell you, this generation kids are extremely, extremely smart. Sir already mentioned it. With the kind of the tool sets that they have, the AI coming into picture, they can do wonders. What they need is a right problem statement and some incentives so that they can get onto the board of that open source. So that answers probably all the 3 points that you mentioned.
No, again, I think we can all, yeah. Again, we'll restrict applause because we are just running out of time. We can do it at the end. But we can all agree that this campus is definitely an outlier. So, Rahul, based on your experience of talking to tens of colleges over the last 2 years, what is the broader picture like FOSS in education?
So I think the only thing I want to say is you said the only thing you do is integrate them into assignments. I think that's a gargantuan task. So just thinking about all the additional work that needs to go in to be able to set these things up. So just my experience going around, right? Just like, how many folks here are not doing one of the flavors of computer science? Everyone here is doing one of the flavors of computer science? Like, no. Okay, so one person who's doing some core engineering, a few people who are doing core engineering. Okay, no, like, so the numbers are going up. The reason why I'm asking this is there's this significant impression that the free and open source software community is by software people for software people. That is not the reality. Like, I'm here from a physics background. And the reason why I got into this is because a professor told me that, look, you just need to write some code to create these plots about something like astrophysics, some cosmology model. And they said, fine, you figure it out. I don't really care what you use. They said, like, use some language. A language called Python is picking up interest right now. Why don't you use it in that? So that's how I got into this. I still keep running into so many students both from a core computer science background, but also from a general engineering background across the country. And it's surprising how the computer science folks have at least heard about what free and open source software is, but they see it only as a computer science thing. And then I've run into people from engineering backgrounds who've used maybe a few tools which are free and open source, but they have no idea that these things are free and open source and that they can participate in these projects. So one of the things that I've been trying to tell practically anyone that I run into is if you're from one of the computer science flavors, find some domain that you're interested in, any domain, right? Maybe you like physics, maybe you like chemistry, maybe you like some sort of like applied math. Find some sort of a domain that you're interested in and use your computer science skills to be able to solve problems in those domains, scientific or engineering domains. And the same thing for the folks who are not doing computer science. I'm trying to tell them that, look, please pick up just enough computational skills to be able to build software solutions that solve problems in those things. And there's also a significant amount of assumption that one, you either have to contribute to an existing thing, which is a significant step up if you've never done anything of that sort before, or they believe that they are just going to continue building out like things of their own, which is going to be the next big thing, which end up being course projects which never go anywhere. Right? This is one of those toy little problems which never end up getting traction or which just never go beyond like a few weeks or a few months of building. But it's surprising how many different kinds of open community contributions can happen even within a college environment and outside. Maybe all you need to do is just put up your curriculum out of a PDF file and into a very simple website that all of a sudden becomes much more easy to navigate, easier to search, easier to integrate. And then maybe once it's online, people will start saying that, hey, look, this is not included as a meaningful resource in the official course curriculum. Maybe let's include this online course that's available, this free and publicly readable book, open book, etc., etc., etc. But the important thing is people assume that you have this huge jump to make to get into the free and open source ecosystem, but that's not the case. And people also assume that software is the only way that they can get into the free and open source ecosystem, and that's not the case. The digital commons are incredibly vast. It's important for you to ask yourself the question, which and what kind of problems am I interested in? And then that will naturally lead you to figuring out what kind of software either exists, which is free and open source that you can work on or contribute to, or it will help you figure out, okay, fine, if nothing exists, then who are the other people around me, people with domain expertise or people with computing expertise who I can work with to build these things out.
I'd just like to add one point, Ansh. So Rahul mentioned that it's a lot of work to integrate these things in the courses. But then I have a question. In the world of AI, what else is the relevance of a teacher? Teaching is going to be all done by the students by themselves. This is the only thing that teachers should look forward to be doing in the courses, to have world-class assignments being listed and being the mentor. So I think if the sooner we understand that let students learn by themselves, but let us become their mentors and guides in successfully enabling the projects, that's gonna help. That is point number one. Point I forgot to mention that there are a lot of open source programs like the Google Summer of Code, the Linux Foundation. There's another thing that I have adopted in my course. If a child comes and says that I want to write an application for LFX this year, let's say Sridhar is here, we work a lot on Linux Foundation has such fantastic internship programs. Let's say a student comes and says that I want to write an application and want to participate in this program. I don't give any course assignment to that student. And I say, let's work on that application. You get selected or you don't get selected is not important, but to prepare an application itself for LFX is a huge task. And even if you fail, you actually succeeded in learning. So yes, I think as of now, it is difficult to add these things in the course project. I'm happy I was able to do it 10 years ago, but I think we'll be still able to stay relevant if we continue to do this. So we should spend time on that.
I just want to add the AI part of like my answer because I guess every answer now needs an AI context. It's surprising how many people are relying on AI summaries right now of anything and everything that you're reading. And one of the things that you need to become a software architect or like a CTO or a person who has the significant software understanding is to read code. I don't know how many of you read code as part of your computer science education. An educator called Greg Wilson put out this question recently, saying that why are so many computer science pedagogies place no emphasis whatsoever on reading code, and there's just so much good code out there, absolutely amazing code out there, which you are never going to directly get exposure to unless and until you actually take the interest and to go out there and say, okay, fine, like what sorting algorithm does Python actually use? How is React implementing a whole bunch of these different like data structures and algorithms? And it's extremely important, and the huge amount of learning from the open source ecosystem, and something that you're not going to get from an AI either. Uh, so don't fully rely on like some of those summaries either. Like please take the interest to find a project, understand how that code has been written, why people wrote it in the way that they wrote it, because that is where you end up understanding the nuances and the best practices of how software is being built out in the open.
That's a very relevant point, though. The ability to read code, and and the only way that will come to you is if you're actually immersed in the process itself. It's not going to come from. You're not going to be able to deal with it just by reading, Claude generated summaries and so on. In the real open source development process, you actually have to read code. As a subsystem maintainer, I spent enormous amount of time reviewing other people's code and things like that, and that is a very, very important part of the engineering process as well. And again, I would really support what the transformations in pedagogy. And then again, my time and current time, there's a huge difference. There is the technology, the open source projects, internet, everything is now available. So things are very different, and you can actually do that. Given all these capabilities and facilities that are there, I think the pedagogy has to change dramatically so that the experience is a lot more immersive rather than just looking at what the finished products really look like, right? How did the finished products got to be what they are? You have to immerse yourself in that process, figure it out. And only way you will figure it out is by actually kind of going through that process, arguing with the maintainers in terms of what your design proposal is, getting an implementation out, reviewing other people's code, finding bugs, solving problems, and taking care of users, your user base in the long run. If you don't do this, you will never have that immersive learning and so on. So in that sense, anything that we can do to kind of change the pedagogy fundamentally for all subjects, including computational sciences and other sciences as well, right? I think time has come, and the situation is just ripe for us to kind of have that sort of transformational change in the pedagogy itself. So to the extent what I think Professor Mohit is talking about, I definitely endorse that from industry perspective, and the former student who did not have all of these sort of technologies surrounding us when we were students.
Yeah, no, thank you for all of you for that. Rahul asked this morning if there is an awkward question on the panel. So we've all been discussing how perfect all of this is, right? Open source is so good and it just makes so much sense. So why do we still have to have these discussions? Like, why are students still doing lead code all day, and why are institutes still paying for Windows licenses? Like, what is the problem here? Any Rahul, maybe you can go, and all of us, I think, all of you can.
Professor Mohit pointed it out earlier. It's about incentives. How are you incentivizing the students? And like there's definitely a small percentage of students who are just like in some ways nuts, and they're going to spend hours and hours in a lab until 4 a.m. in the morning, who don't need an additional incentive. There are people who've been able to find a financial incentive, so they get into like a GSOC program, and then like they get paid to be able to work in open source projects. But there needs to be a lot more incentive like in academia, right? I think we need to be able to say that, look, we are going to reward you with grades and like marks by doing meaningful, diligent work in the open source ecosystem. And one of the things also is that there have been only a few examples of this, and there have been just so many more examples of proprietary and closed source ecosystems doing incentives, right? Like because there's a significant amount of financial incentive for MATLAB to go and tell a college, no, get a site-wide license, or for ANSYS to say, no, get a site-wide license. And then all of a sudden, the students are being taught tools and not fundamentals. It's a very, very easy and slippery slope to go down.
Oh, that's an important point. I think commercial software, proprietary software, they have people behind to market, create a brand, and say that we are there to fix anything. It's a boilerplate code; it won't crash. And some of that is, so FOSS also needs maybe champions, brand building, marketing. Maybe some need not be fully free. It can be very tiny, tiniest percentage, but that will keep it alive. And you have to be able to convince. End of the day, if there's an alternate to PowerPoint or Excel or Word, whatever is there, but if that software cannot open a normal Word file without getting corrupted, then people will not do. So sometimes these pain points are very tiny, but decision makers will get annoyed with those things. So that has to be worried about. And other point is that not everything has to be free and open source. You have to pick your battles, saying that okay, these things make a lot of sense in being free and open source, and the proprietary private guys, their attention is not on these things. They won't come and beat you up in the market. So we have to pick our battles and maybe champions and build the brand. I suppose. I mean.
Just to quickly add one point. So you all might have noticed that the projector went off twice when Kailash was speaking today, right? That was that projector. We have a problem with its HDMI cable because that HDMI cable goes somewhere down and gets connected to that podium, and something has happened. That HDMI cable is gone. Some rat or whatever. We don't have them in the room right now, but they may be down there somewhere. We don't know. So HDMI has been a problem, and they said that we'll have to take off the floor and find out where it is, and it's tough. So use Wi-Fi on that. Okay. And so we have to use Wi-Fi. And the problem that we were facing was we were actually using that laptop, and Wi-Fi fluctuations were leading to the projector going off. Now, one of the unique challenges that I face, and that answers what Ansh's question is, to use that projector in Wi-Fi, I need to install an app which is only supported in Windows. I cannot install it on an Android phone. I cannot install it in a Ubuntu or any Linux OS for that matter. I cannot install it in Mac. I cannot install it in any system. It just has a support for Windows. So it will be great if we could talk to those guys and tell them that when will they start giving us apps which work on open source so that I don't have to do. And you know what? I know how things fail. And that is why we always have a plan B. So this is, you can see, if you can't see from there, I can see this. So yesterday evening, I contacted my colleague Prithviraj sir at night 10 p.m. Do you have pretty long HDMI cable? Because I have to have a plan B projector, and thanks to him, there's an HDMI cable actually running from this projector all the way to podium that saved us for the rest of the presentations. But what do I do if the vendor is not providing me any support in terms of open source? What do I do? Same problem I have. I'm managing the campus network, and my campus is the size of 25,000 devices. I am forced to use a commercial firewall. I am now trying to make an open source firewall using eBPF, XDP, DPDK, and our own students are building, and that's a long running project as a course project. But until that firewall gets built and I can scale it up to 25,000 devices or 30,000 devices, I am forced by these vendors to use tools which I probably may not want to use, but there's no option left. So, we have a long way to go to, and that's why these discussions are important. We still need to talk about FOSS again and again.
So reverse engineering the projectors, protocol could be a good student project at some point in time.
Sure.
I mean, it is allowed by Indian laws, so it could be a good student project. But I agree. But also now seems like then for tomorrow I have no way of connecting to the project. Since I run Ubuntu on my
We have the
laptop.
other one, no? No, we have the backup one.
Yeah, I know. I'm
So,
just kidding.
yes. No, I'm not gonna touch that now. So it already went twice in 20 minutes. So yeah, but anyways.
No, I think one thing we keep going back to is how these corporations are spending so much resources on just penetrating all of our institutions. Maybe we need like our own little open source lobby, of people like us who can just keep lobbying for FOSS. We still have time. We'll close then. Yeah. So I had a bunch more questions, but it's fine. Closing thoughts from everyone, maybe, and if you can, with that, if you can give us one actionable commitment that all of the students here can follow in the next semester, and maybe if there are other institutes here, professors, they can follow in their own institutes over the next semester. Any closing thoughts and one commitment from all of you?
We are trying to position NITK entire 300-acre campus as a living lab. Okay, we came with this theme of 6S, which is smart, sustainable, swachh, surakshit, and samrit campus. But you can add some more S's if you want to do that. We just created a new lake in the campus, which you can go and see, a new landmark to solve the water issue here. But I want to make it as a smart lake. Can I put some sensors into that? Can I beam the thing to that? Can we people monitor that? So through him and through all of you here, if you can identify, even just walk around, you must be having some time to walk around the campus, right? And if you see, pick one thing that you think that you can offer to NITK, either individually or a group of students, 2, 3, 4 students, saying, sir, this part of the campus, I'll make it smart in some way. And if it does not cost too much money, we give you access to the institute through maybe him or his group. And you pick up a project where with a small amount of money, we can try to bring it to life. The whole NITK will be a test bed for your experiments. So you're welcome to do that.
I think we have spoken on the open source part about the commitment. So I always try to see what is the way that we can incentivize students. We have now started getting funding on open source projects. So I would say that one of the directions that we should look is, yes, we have ANRF, we have government support, we have a lot of funding coming from government now, but there are so many other funding opportunities. Like for example, Zerodha has started the funding opportunity. But besides that, there are at least 20, 30 organizations that alone I know. And we should create a database of all such funding opportunities that open source provides and ensure that the students participate in writing some of the funding proposals, get those funding and execute the projects. So I would say that as a part of my commitment, we already have received a good amount of funding from 4 to 5 funding agencies that have a requirement that they will fund only if you make your work open source, and I'm more than happy to do that. So as a commitment from my side, I'm happy to mentor the students if they would like to write some proposals, and I can personally be involved with them to see to it that we can make through some of the proposals and get funding on open source.
Give a chance to these students and others to a hackathon. Is that possible?
Yes. So yes, we can. So a lot of students use open source during the hackathons and all. There are several ways by which we can incentivize. Just a small hint. Just before we break for the lunch, after an hour or so, we have prepared some special goodies. And when all the people had registered for this conference, we sent out an email, sir, to all the registered participants that if you have ever contributed to any open source tool, it could be a small documentation or it could be a small bug that you fixed, please fill this form. And I'm happy to tell you that 12 people in this room have actually made tremendous contributions to open source. And when people like Kailash, Sridhar, Deepankar sir, director sir, Rahul, when all the other fantastic speakers are here, we have just made a small set of goodies and we will be actually honoring them on the stage for their contributions on open source. Just a small way by which we want to recognize that, you know, they have been contributing to something that the community uses. So just some ways of incentivizing. If there are 600 people here, if everybody brainstorms and comes up with an idea as to how you can give incentives, I'll be more than happy to talk to you and learn from you on that.
Just want to kind of add to what just said, and Professor Ravi. I mean, I love the concept of living lab, and also this, the new things that have been introduced in the curriculum for people to go out and for students to go out and solve real world problems. Bringing in engineering approach to solving problems and so on. And in general, I would really, really encourage for all students that approach. Anything that doesn't work with open source, you should look at it as a problem to solve, right? Rather than just throwing your hands up and then basically saying, I actually talk about my own journey with open source, beyond the IBM bias or whatever, right? how I made a 486 Pentium 486 DX2 PC with Linux 0.91 in 1994, make it work basically, right? Because my sound card was not working and I could go and make it work. So the point is that, it is about solving the problems that you are facing, your friends are facing, your community is facing, and so on. So you should not look at some of these challenges that you see in the open source world, or compatibility issues, or any other issues, reliability issues. You should see them as actual real world problems to solve. You should go and solve them. And from an academia perspective, from a pedagogy perspective, if they could be credited on, if they could count as something, that could be really, really helpful. And I can say this as a industry veteran, someone who has been in the industry for a long time, and someone who recruits, hires, and recruits people as well. Those skills are highly valued, as opposed to just purely academics and CGPA. CGPA counts, so by no means you should lower your CGPA, but these skills matter a lot. A lot of people come to us with 8 CGPA and 9 CGPA and all that. These are things that differentiate between people in the long run, right? So so you should pay attention to that, and really, really take advantage of all of these opportunities that are being provided in this space.
Rahul, any point?
Yeah, we are in a college, so a take-home assignment for everyone: read one piece of code, free and open source code. A lot of people here are using Android. I'm guessing all of you either use Firefox or Chrome. Firefox, the software is available for you to read online. Chrome is based on Chromium. It's available online. If you're running Linux, the desktop environments are like freely available. The Linux kernel is freely readable. There are tons and tons of free and open source software that every single one of you is using. At the very least, each of you is using at least one free and open source software. So please go back and read at least one piece of code from those projects. The commitment on our end is over the last year, we've given out more than 25 lakhs in grants to Indians who are building open source projects and contributing to the open source ecosystem. We'll continue doing that. So yeah, if any of you end up actually participating in any of these ecosystems, we're more than happy to support you financially. If not, like support you in any other way possible.
For students specifically, if you could also talk about the making curriculum accessible project that we've been proposing.
Yeah. Again, there's a ton of different ways in which like you could participate. But yeah, like please at least read one piece of code.
One commitment from my end, our annual hackathon is happening in March. It's called FOSS Hack. It's our premier hackathon. We've changed the format this time. It used to be a weekend hackathon. We've made it a month-long hackathon now because we want people to build meaningful things, and we'll also have partner projects that you can contribute to. So you'll have a lot more this time to contribute meaningfully to actually mature, stable projects. Please check that out. The team is here if you want to chat. Yeah, thank you so much for taking out the time. Thank you for listening.
Thank you.